Right, this is your solving compound inequalities topic where you see and or statements. So our first example is an or statement. We have two separate inequalities. So what we have to do is we need to solve each of them individually. So we're going to go ahead and solve them like an equation. Subtract 2 from both sides to get the variable term by itself. And then if you guys remember, when we have a negative x, we have to divide by a negative 1. But we also can't forget that we do have to flip the sign when we multiply or divide by a negative. So then we get x is less than negative 1. Solving the other one, add 4 to both sides, divide both sides by 2, we get x is less than 5. We did not have to flip the sign because we divided by a positive number. And again, remember, it is an or statement. So step number 2, graph each of them. When we have what we call our critical numbers, we use them as the two kind of guidelines on our number line. So our critical numbers are negative 1 and 5 because those are the numbers that we got by themselves on the other side of the inequality. So I graphed the first one. I needed an open circle at negative 1 because it's a less than sign, and x is less than that, so it's going in the negative direction. Graphing the second one, we need an open circle at 5 because it's less than, and again, less than means we're going to the left. However, this is not our solution, this is just graphing each of them individually. So when we see the word or, it means one or the other or both. So that any of those lines you see are solutions because it's an or statement. So our final solution, again, is that overlap. See where I highlighted where I saw any solution. So I got a solution all the way from 5, keep going left, and it picks up at 1 and it keeps going. Therefore, my final solution is going to be an open circle at 5 and any value to the left because or means one, the other, or both. Our second example is another or statement. So let's look at this one. Again, the same steps as last time, solve each of them individually. Again, we cannot forget to flip our sign when we divide by a negative. So my less than sign becomes greater than sign. On the other side, since I was dividing by 5, to get rid of it, I multiplied by 5. Again, I multiplied by positive, so I did not flip my sign. Again, my critical numbers are negative 2 and negative 5. Don't forget that negative 5 should be on the left because it is less than negative 2. So just a side note, our open circle or closed circles, because we have a greater than or equal to, we need a closed circle, less than open circle. So if you have arrows going opposite directions, that's your answer. You don't have to worry about regraphing for the third time because both of those are solutions. Anything greater than or equal to negative 2 or anything less than negative 5. One or the other, no overlap is needed for an or solution. Now we're going to move on to and statements. Here's our third example, and note that the word says and this time. We got 2x is greater than or equal to 5, and x plus 7 is greater than 6. Let's solve these. So just in parentheses, I wrote 2.5 because that might be easier for us to see on the number line. And then the one on the right was very simple, just subtract 7 from both sides. My critical numbers are negative 1, and because on a number line we don't use decimals, I did 2 and 3 as tick marks because I know that 5 halves or 2.5 is right in between. So let's go ahead and graph both of them. X is greater than or equal to needs a closed circle and it's 2.5, and then x is greater than negative 1. Now here's where it's different because it's an and statement. And solution is the overlap. And means both have to be true. So we can only say the solution is the overlap. So see where I highlighted was where the two lines overlap, therefore that was my final solution. Anything greater than or equal to 2.5, because it has to be a solution for both. So a nice way to look at that is where do my two lines overlap for that and statement, and that's how I got my final answer. Nothing to the left of it is a solution because there's only one. Has to be both. Fourth example. This is a different format It means and. So anytime you see a combined inequality, so two inequality signs with one statement, it means it's an and statement. So what you do is you solve the equation, but what you move from the inside, you have to move or do to both of the outsides. So I'll show you what I mean by that. I need to subtract 2. So I'm going to subtract 2 from 14, and I'm going to subtract 2 from -7. Whatever I do to the inside, I must do to both outsides. So when I do that, I get -9 and 12 on the outside, and then I'm going to divide by 3 in the middle, so that means I divide by 3 on both my outsides. Final is going to be -3 is less than or equal to x, which is less than 4. This means x is in between, so x is kind of sandwiched in between those two inequality signs, so that means x is in between -3 and 4. The solution is in between -3 and 4. So I graph my first closed circle because -3 has the less than or equal to sign next to it, and then the 4 gets an open circle because it's got the less than sign next to it. The solution is in between, so you draw a line connecting them. Last one. And when we solve our equations, we might get something like x is less than 4 and x is greater than 10. When we go to graph those, we have arrows going opposite directions and there's no overlap. For an and statement, we have to have overlap. Therefore, we have no solution.